When police pull a victim from a freezing river at night, the immediate assumption is obvious. A person goes into the water, they struggle, and they drown. But for a forensic pathologist, a body recovered from a lake or a bathtub represents a reconstruction of events where the physical signs are often misleading. Water acts as an active agent of destruction. It washes away external evidence. Bleeding, known as a vital reaction to an injury, is diluted or stripped away entirely, making lethal wounds look like post-mortem artifacts. Because of this interference, forensic pathology operates on a strict rule. Discovering a body in a body of water does not prove the victim died by drowning. This diagram outlines the 5 distinct diagnostic pathways a pathologist must navigate. The victim might have suffered a natural illness, like a heart attack, before falling in. They could have sustained fatal injuries on land. They could be the victim of post-mortem animal predation, or they could have died from dry drowning or wet drowning. Finding the correct pathway is a race against biology. Once a submerged body is pulled into the open air, the rate of putrefaction doubles. Because bodies typically float face down, blood pools heavily in the head due to gravity. When exposed to air, this rapidly destroys the victim's facial features and identity. With the external environment actively erasing the crime scene and the air deteriorating the body, investigators must abandon the surface entirely. To find the true cause of death, they have to look deep inside. On the autopsy table, the primary focus shifts immediately to the victim's respiratory system. The lungs hold the physical record of the person's final moments. In cases of wet drowning, formerly known as emphysema aquosum, the body undergoes a violent physical struggle to survive beneath the surface. The victim gasps, pulling large amounts of liquid directly into the airway. This cross-section of the lungs illustrates the immediate chemical reaction. The aspirated water violently churns with the body's natural lung surfactant and edema fluid. The resulting mechanical friction whips these liquids together, producing a massive volume of dense foam known as classical froth. As the victim continues to struggle, this froth hyperinflates the lungs. They expand outward until they press tightly against the inside of the chest cavity. The pressure is so immense that the rigid bones of the rib cage actually leave deep physical indentations pressed into the lung tissue itself. The classical froth that fills the airway is entirely distinct from normal fluids. It is bright white, tenacious, and produced in such overwhelming quantities that it often bulges out of the mouth as a continuous plume. The bubbles are so thick they cannot even be popped with a steel pin. But pathologists also encounter a biological paradox. Sometimes a person is recovered from the water. They clearly suffocated, yet their lungs are completely dry. This is dry drowning. The sheer panic of submersion triggers a laryngeal spasm. The airway violently seals itself shut to keep the water out. The victim suffocates on their own defense mechanism, leaving tiny internal bruises called petechiae scattered across their organs from the immense venous pressure. Identifying whether a victim's lungs are filled with unpoppable classical froth or marred by asphyxial petechiae gives investigators their first concrete biological proof of exactly how the body reacted to the water.
These internal signs are the exact details killers try to exploit. By intentionally drowning a victim or dumping a deceased body in a river, murderers rely on the water to mask their involvement. In the infamous Brides in the Bath serial murders of the early 1900s, the killer repeatedly staged homicides as tragic fainting accidents in the tub. To catch a staged drowning, pathologists examined Audie for signs of prior incapacitation. If a victim was heavily sedated with alcohol or drugs, they cannot mount the violent physical struggle required to generate classical froth. If a victim is already deceased before they are dumped into a river, the mechanics of drowning are biologically impossible. A dead body cannot inhale. Without inhalation, no froth is generated, and the lungs never overexpand to press against the ribs. This creates a specific diagnostic gap. If a killer successfully dumps a body and the flowing water washes away external injuries, how can a pathologist scientifically prove the victim took their final breath underwater rather than on land? The answer relies on diatoms. These are microscopic, unicellular algae that live in almost all bodies of natural water.
they possess incredibly durable skeletons made entirely of silicon. This diagram outlines the biological transport mechanism at the center of a water investigation. When a living person breathes in lake or river water, they also inhale thousands of diatoms. Because the victim is still alive, their beating heart actively pulls these microscopic algae from the lungs, pumping them through the bloodstream until they deposit deep inside closed tissues, like bone marrow. If a dead body is thrown into that same river, water might passively seep into the airways, but without a beating heart to pump the blood, the diatoms cannot circulate. The bone marrow remains empty. To extract this evidence, forensic labs take samples of the victim's bone marrow and subject it to extreme degradation. They submerge the tissue in boiling nitric acid or incinerate it entirely to ash. The organic human tissue is destroyed, but the silicon skeletons of the diatoms survive the acid perfectly intact. Placing those surviving silicon skeletons under a dark ground microscope provides the answer. Finding diatoms buried deep inside the marrow is biological proof that the victim's heart was still beating when they went under. A forensic pathologist never issues a final ruling based on a single microscopic slide. To finalize a cause of death, they must triangulate three distinct factors: the scene's circumstantial evidence, the water's specific features, and the body's internal pathology. Cross-referencing these elements is the only method to rule out a pre-existing condition, like ischemic heart disease, or to detect blunt force trauma deliberately hidden by a staged accident. For centuries, killers have relied on the chaotic, destructive nature of rivers and oceans to serve as their accomplice, washing away the vital reactions that point to murder. But a body keeps its own rigorous ledger. Hyperinflated lungs pressing against bone, the chemistry of unpoppable froth, bruising from a sealed airway, they all leave a permanent record. The water's surface may erase the crime scene, but forensic science ensures the microscopic debris suspended inside it